Alright chemists, we're back for what I think will be part 2 of one lesson, so thanks for hanging in there. Alright, so now we're going to talk about the symbols and the basics of atomic structure. Okay, now this will be mostly revision with a little bit of new stuff, particularly when we start talking about electrons. And where it's new stuff, it's not completely new stuff, it's mostly just finer details. Alrighty, so this is the way we draw our nuclear symbols, and we see these on nucleus, the nucleus, the atom. This is the one you see on your periodic table. So E is for element. A here is where we keep the atomic mass, that's always at the top. The atomic number, which we symbolize with Z, so get used to that. That's a Z. That's always down the bottom. So A for atomic mass, which is measured in atomic mass units, you should know that by now. And Z, which is our atomic number. Okay? And that's down the bottom. This is E, that's the one that we replaced with the H for hydrogen, the Cl for chlorine, etc. Always a capital, blah blah blah, you should know that stuff. Now, the mass of a proton, so that's M, big M, little p, the mass of the proton is equal to 1.007 AMU, and the mass of the neutron, so that's the little N for Nelly there, is 1.008 AMU. Now, those not quite even numbers, that's not enough to give us the variation of, all the points on there. That comes down to something we'll talk about in a minute when it comes to the atomic mass, as to why they're not full whole numbers. Alrighty, so this is roughly what we're used to seeing. Okay, we call this the Bohr model of the atom, after Niels Bohr. Positive nucleus. Okay, you know that's where the protons and the neutrons live. Size-wise, it's about 0.001 of a picometer, which is really little. So it's picometers. Whereas the total width of the atom, radius of the atom is about 100 picometers. Now, that might be new. This is new. You've got your electron shells. Now, sometimes they're called shells. The more correct term is energy levels, and that's the way we'll refer to them. They are K, that's the first one, L, M, N. Okay? Like the alphabet, it's in order, they're not trying to be tricky, but they start at K, so it's K, L, M, N. Okay. Alright, so Z is the number of protons, and it's also your atomic number. So the atomic number is always the number of protons. Okay? A, so the atomic mass, is the average number of protons and neutrons. Now, alright, we'll jump into that bit first. We'll skip this, we'll come back. Isotopes. So an isotope, many atoms have this, and it's a variant form of the atom, which means a different version of it. Okay? So, but they're only different number of neutrons. If they differ in anything else, it becomes a different atom. Okay? It's the number of protons, and consequently electrons, that define the number of the atom, like the type of atom that it is. So, carbon has 3 isotopes. It has carbon-12, which has a mass of 12, carbon-13, and carbon-14. Overwhelmingly, the most common is carbon-12 at 98.9%. Of all the carbon in the world, 98.9% of it is carbon-12. Now, carbon-14 is actually radioactive, and we use that for carbon dating, so that's cool, but that's a different story for a different day. So that's an isotope. Electrons. This here is a very short way to write electrons, just the E minus. So they occupy stable energy levels, there's that word again, around the nucleus. They're 99.99, that's actually 3 more 9s on there by the way, percent the volume of the atom. Volume, not mass. They're negatively charged, we know this, so they're the opposite of the proton in charge. And they have roughly equal and opposite charge to the proton. The mass of the electron is only 0.00055 atomic mass units. So they're really, mass-wise, they're really tiny. So that's a 10,000th, 5/10,000th of the mass of a proton. They move rapidly, like they move so fast that we tend to not really refer to them as individual electrons, but as an electron cloud. And each cloud exists at a different level. In a neutral atom, the number of protons equals the number of electrons. Alright? You're doing well, hang in there. Not much more. Alright, so let's look at how we represent these things. If these are our energy levels, 1 to 5, these are the symbols for it, KLMNO, and the max population of electrons. So the max number that you can have is 2, 8, 18, 32, 50. And that's determined by the formula 2n squared, where n is the energy level number. Okay, so 2 squared is 4, 2 times 4 is 8. Alright, we come down here, 5 squared is 25, 2 times 5 is 50. Alright, this is one way we can represent it. So it is energy, so it's a graphical representation. So as the energy increases, it goes up, the number of electrons increase. So here's the K shell, it can only hold 2. Don't stress about these breaking up at the moment, we'll get there. But right now, don't stress about how that is broken up there into sub-levels. So the K shell, the L shell, the M shell, the N shell, and if I hadn't have run out of room, we would even have an O shell in there. I said O something else there. Now, little summary on electrons, and then you're done. You've done well. We're almost finished. First off, they fill the lowest energy level first. I'm about to tell you how that's a lie in a second, but generally they fill the lowest level first. The max number determined, so the maximum number in each level is determined by the formula 2n squared, we've talked about that, where n equals the shell level. The pattern of electrons though is called the electron configuration. Now, we write each shell in order with a comma between. Okay, so sodium, that's Na, its electron configuration is 281. 281, that's pretty cool, straightforward. And here the M shell can contain 18, but it's not filled at all until we get to copper, which is, what would that be? That would be 29. So, and that's where it says 2, 8, 18, 1. So, elements 19 to 28, they actually have incomplete M shells, and we'll get to that further down the road. Now, there are 3 ways we can represent this. First, this is the basic that all this relates. So there are 2 ways, but this one here introduces us in. So Z is 19, the element is potassium, K level has 2, then 8 in the L, 8 in the M, and 1 in the N. To represent this graphically, like we had before, but without doing all the dopey circles, pictures of the electrons, we can go K, L, M, N, so it's 2, 8, 8, 1. The very simple way to write this is, in this case, K equals potassium, so that's the elemental symbol. Potassium, the electron configuration, know that phrase, is 2, 8, 8, 1. Alright, that's it. Cool, sweet. See you in class.